So if you come down a little bit more, yes, yeah. As you can see here, we have given this turn on. So we have given turn on. It's a number of LEDs that are on. Okay. So this is what we have given. A binary watch has 4 LED, right? If you go little up, if you see here, right, it has 4 LED, right? So the 4 LED we have is a LED that contains 4 hours, means 8 4 2 1. This is for hours. So this 4 LED is for hours, and for this this is for PM and AM, whatever we will say. Okay. And the 6 things we have is 32 16 8 4 2 1 is for minutes. These are for minutes and these are for hours, right? So the total LEDs is 6 and 4 is 10. Okay, this is what we have given in this problem, and you can read from here also. A binary watch has 4 LED on the top of the representation 0 to 11 and 6 having 0s to 59 as a minute. So each LED represents a 0 or 1 which least significant bit on the right. So for example, if you say the below watch reads 451, then you can say this is 4 and this is 51. Okay, how this will work, that is a different thing. So we'll understand. Very first, that you have seen that for the binary thing, right, this binary watch contains 4 LED, 8 4 2 1 for hours, and these 6 things from 1 to 32 it contains is 6 LED for minutes. So the total load we have is 10 LEDs we have here. Okay, basically this is how works. You should understand how this watch works. Okay, so we have hour, right? In hours we have 4 bits, right? So these bits are 8 4 2 1. Okay, and for minutes we have these 6 bits, right? So these 6 bits are separately 1 2 4 8 16 and 32. These are separate. So each LED represents a power of 2, right? And if it's on, it has some value, it will add the value. Okay, and if it is off, right, it's add the value as 0. For now here we have 4 for the 451, right? We have, it is saying 451, right? For the 451 it is 4 is on, right? But in the down, if you say only those are on who makes 51, right, as a as a value, right, it's add. So 1 2 16 and 32 are on, and 8 and 4 are off. On the up we have 8 to 1 are off. Like this, these are on and these are off. So this is what we have given in this problem statement here, right, for what is on and what is off. Now think that if this Rs1, if Rs LED look like this, right? For understanding how, let's see. If we have 0 1 0 1, it means this one is on and this one is on. Okay, rest are off. So you can represent like this. It means the 4 for this one we can say 4, and this is for 1, right? It gives you what, 5, right? So R is 5 hours we can say. And for the minute, let's suppose if the minute look like let's call, we have 0 0 1 0 0 1, 6 digit, right? Means the 8 is on and the 1 is on, rest are, we have 0 0, guys. Okay, it means the 8 and 1 is already there, rest are 0 value addings. It gives you 9, right? 9 minute. It means total is, what is the total time here? So total time, you know that it will give you 5 509 we can say, right? It is the 509 p.m. am, whatever will be there, right? So this is the 509, 5 hours 9 minutes. So how this binary watch works, it works like this. I hope you understand. Let's try to understand. When we talk about if all valid times where exactly one LED is on, it means everything is on, but everything is off, only one LED light is on. Okay, it means I'm talking about the scenario. So I'm talking about basically this example one, where turn on is one only. So what is the input and output here? Input is turn on equal to 1, and this is what we have in the output. It means what? All the valid times where exactly one LED is on, and this is we should understand. So most important thing we have to understand is hours, right? And we know that hours must be between 0 to 11, right? For the minutes, it should be between 0 to 59. Can we say that? So these things we should understand. And there is also one more thing is format, that we have H and M. It means minute must have a leading 0. As you have seen in the previous problem, there should be 0, 9, and we have created 5. So like that we have given, okay, the format. So if all valid times we have here, when the exactly one LED is there, so it should be, the result should be like this. Okay, basically when turn on is equal to 1, we need exactly one LED on. So there is two possibilities. What are those possibilities are, guys? Let's suppose here itself is we have case 1, right? In the case 1, when one LED is ours, right, there is a possibility that we know that either this will be on, this will be on, this will be on, this will be on. Any of these LED will be on. It means the option are 0 0 0 1. This is the possibility. Either 0 0 1 0 is possibility, either 0 1 0 0 is possibility, or 1 0 0 is the possibility. So these 4 represents 1 2, this is 4, and this is 8, right? 8 4 2 1. So this represents, and this is the possibility. So valid time could be, we say in this way, we can say 1 0 0, then 2 0 0, 4 0 0, 8 0 0, as you can see, right? So this is the possible valid times, right? So this is when possibility is that one LED hour is on, right? When one LED hour is on. Let's understand about the case 2. If I am talking about case 2, how the case 2 will works, let's understand. So in the case 2, we have is 1 2 3 4 5 6, total 6 thing will be there, right? So means case 2 is when one LED is on for the minute, in the minute 1. You're understanding what I'm trying to say? So basically the possibility is that we have these values are there, right? Means the binary, it is 0 0 0 0 0 1. This is on. Next time maybe the 2 is on. It means this time we'll say this one, and rest will be 0. So this gives you 1, this gives you 2. To represent the 4, we know that it will go and it will on this one, right? So 0 0 0 0 you will do. So it will become 4, then it will become this one, it become 8, rest are 0 0, then this one, rest are 0 0. So this becomes 16, and there's 1 0 0, rest of the thing are This is a 32. So like this, we have all these minutes are there, right? That are valid. Maybe the possibilities these are valid. So these are the valid times for when only one is turned on, right? Either one of the binary is on. Now think that if you represent this, it will look like 0, 0, 1, 0. It is 0, 2, we can say 0 hour 8 minute, 0 hours 16 minute, 0 hour 32 minute. Like this, these are the valid. Means total valid is this one time and this one are the times are valid. So if we keep everything at one place, it will be the output like this. Okay. The total answer is 6 plus 8 equal to 10 times we are having the answer. Okay. Basically, if you think how we will approach for this solution, that gives you the optimal answer. The thing is, we know that people here now will try different things, right? But there can be optimal answer. So now here where the most people overthinks, right? They try to do, let's call what you call backtracking. Remember, some of the people will do backtracking, some will do the combination, some people will do the recursive recursion, right? Recursive lead selection, right? So these things they can do. So they, if will they try these things, or if you will try this backtracking, combination, recursive lead selection, so do not do this. Just to stop this, because this will not work. So let's zoom out how to uh, uh, think about the optimal solution. So how many possible time exist here? Just think that. Let me clean it here. So just think that there are 12 hours, right? And there are 60 minutes, right? Total, this means total, if you'll talk about 720 times are there, right? Means total possible times exist is 720, right? If you say anyone, how many possible time exist, so you should say total is 720. That's a tiny, right? So instead of generating combinations, we can just try what? We can try every possible hours, right? Then we can try every possible minutes. Then we can count total set bits, right? That we have seen like that. And then if matches, then add into the result, right? Simple. If the every possible hours are there, we will try that. We will try every possible minutes also. Then we'll count total set bits, and if matches, we will add it to the answer, right? That's all we need to do. This is a controlled brute force approach, and it will work in the interview. So in the interview, smart brute force approach will beat the complicated overthinking engineering. Okay, so try to do this way. Okay, so what this technique is, basically this is a bit manipulation. We will do the bit counting and control brute force approach. We just need to do what, guys? Integer dot bit count, if you remember, right? You can use this. So this method counts how many 1s are in binary representation, right? So you can do that. Let's try to understand the code here. Hmm. So it's a very easy steps are there, right? So very first, what you need to do is you will create a result answer, because we have to return it, right? And for checking all the possible hours is 0 to 11, so we'll start from 0 to 12. We'll loop over the minutes 0 to 59, so we'll go to 59, and total bits we need to find is integer or bit counts from the hours and bit counts from the minute. If total bits are equal to on, right, it means it matches, right? If it matches total bits, what you need to do is just say time string. You will need to say hours, and the what is the minute is here, right? And you will add on the result. So you have to keep adding all the result, and we have to just check the total bits. If the total bits is matching with the turn on, you will keep adding onto the result, and that is why we will see all the result. So I'll put this code into the comment section, guys. You can get it from here. I'll request you to write the time and space complexity, so you will understand the problem clearly. Okay. And if you want to learn DSA Java, you can reach out to me, and that's all I have in this video, guys. So let's connect in some other videos. Thank you.